Oh my goodness, Nish.
That's amazing, right?
Oh, the lights, the music, I've never been introduced like that before.
Absolutely. I feel like a Bollywood celebrity now, you know? It just feels great. It's so much of light on me. And so can I show you some Bollywood moves? Is that okay?
Yeah.
I thought he was going to say no. Oh my God.
Absolutely, please dance.
No. Let's do some real developer stuff.
All right, Reliable Web Apps. My name is Matt Silk. I want to say hello to everybody online. I heard we have 2.7 million people watching us online today.
Wow.
I cannot wait to share Reliable Web Apps with everybody. Like I said, my name is Matt Silkup. I work in cloud advocacy, and this is my friend Nish.
Hey everybody, my name is Nish. I work as the product manager for the App Patterns. We're going to speak a lot about it. So you may ask, what's App Patterns? Well, it's part of the developer division at Microsoft, the same division that brings Visual Studio, VS Code, .NET, C#, and so many amazing things out there, Matt. So we're all about developers, and today we're going to talk about patterns for developers, right? So, Matt, one common question that we get asked all the time is, how do you build apps and deploy to cloud? How do you do that, Matt?
Usually I ask somebody smarter than me, like you.
Oh, okay. So you do right-click deploy from Visual Studio. You're good.
Yeah, right.
No?
Right. That's what I do, right? Click,
No.
deploy, ask you to write the code.
That's wrong. You shouldn't do that. So
How do I do it?
So here's the thing. Many people face this problem where they have existing applications on-prem and they want to bring the applications to the cloud. Now there are many descriptive ways to do that. Like for example, if you have decided you want to go to containers, you patch a Docker file and you go containers, choose Kubernetes. But there are existing applications out there, Matt, which are line of business applications which could take the advantage of the cloud. But how do you do that? There's a prescriptive way to do that now, and that's what it's all about, App Patterns. So the common question that we get asked is, how do other developers take their first step in the cloud? So the whole idea about App Patterns is we built it to help developers go on a journey from a legacy monolithic line of business application to something like a B2C application in future. So yeah, it's a prescriptive guidance and also a reference implementation. And unlike usual samples and things like that, this is more like a production grade application. So everybody can take a look at it, how it's implemented, and then go deploy it for yourself in your own environment as well.
Great. Yeah, so Nish, what I liked what you just said there is prescriptive. And so what this overall is that it's a pattern of patterns, right? And so it's prescriptive. So at Microsoft, we are really, really good at saying, you know what, you can do things this way, that way, or the other way. It's your choice.
Yeah.
With this reliable web app pattern and overall at the enterprise app patterns, we're going to say, do it this way. This is the best way. This is your avenue to success. And so overall, let's talk more about the reliable web app pattern. It's built off of 5 distinct pillars to it, right? So each one of these pillars are going to have patterns that are a part of it. And what's cool is that each of the patterns that are a part of the pillars, they might overlap, which is neat. Like, so one of the patterns that we'll talk about is like a scalability pattern, right? It could go within cost optimization. You scale down, keep things under your expenses under control. Scalability can also be part of performance efficiency. Scale out, make things faster, and so on. So these patterns can exist multiple places, which means that you can pick and choose which one of these pillars that you implement. Implement the whole thing? Great. Only have time to implement one thing? Perfect too. You can't lose the way you implement things. And we didn't just make this up out of nowhere. A lot of times I just make stuff up, but Nish doesn't. This stuff is actually implemented from our customer engagement team, real-world customer engagements to pick this stuff up. We also use the Azure well-architected framework to devise this pattern, this prescriptive pattern, and also the 12-factor application methodology. So it's real-world tested, coming from real-world methodologies and application frameworks, put it all together, and it's a winning thing. So it's a pattern of patterns composed of 5 different pillars that can be implemented together or implemented separately, and it's a reliable web app pattern.
Yeah, also I want to touch upon, this is the first pattern that we are building. There are more patterns to come. So this is on a journey. Like, for example, as I mentioned, reliable web app pattern is more on taking a line of business applications and patching, applying the app pattern, which is the web app pattern, which we'll look at it in detail in a bit. And then you go on a journey. So your probably the next patterns would be more elaborated, and it will all touch upon these pillars right here, Matt. And this is Azure well-architected framework pillars. So they give you guidance, they give you best practices, they give you developer patterns. So what we did is we showed how to do that in the right way. And as you said, it goes through, it's a similar thing how we build products out here, right? We know that the problems exist, a lot of customers face, and we built, what we did here is we built a fictional company called ReliCloud, which we're going to talk about it in a bit, and a common business problem that we all face, and then applied this RWA, which is the Reliable Web App pattern, and we'll see how we go on a journey in expanding into a large B2C application in future. All right, Matt, so let's talk a little bit more about the Reliable Web App pattern. And as Matt mentioned before, there's this pattern of patterns, there's best practices, there's so many things out here. But underlying all the patterns that we're going to build in future as well will follow the principles that's right out there, right? It's built on well-architected framework. It has 12-factor apps methodologies. We built on .NET. There are future languages coming, as well as, Matt, we did Azure Developer CLI, which is amazing.
Yes.
So easy way to build and deploy applications to the cloud. It reuses the infrastructure as a code implementation. It makes it easy for developers to deploy to the cloud, right? And you can use the same infrastructure as a code for your DevOps as well. So we went ahead and did that, we took care of the observability, SLO measures, and so much more. And for this pattern specifically, we focused on reliability, where you have reliable service communications, we have performance efficiency patterns like cache aside, there are number of security best practices like managed identity and secret management, immutable infrastructure, and 99.9% SLO. How do you meet that? How do you meet that production grade SLOs? So we have gone ahead and implement that right inside this implementation, Matt. So take us through the ReliCloud concepts.
Yeah, so we'll switch over to the demo right now. And this is what you will get out of the whole package that we delivered. So this is the application. This is production ready and ready to go. Well, the only thing that's not production ready are the graphics and the way it looks. And the reason we didn't do that, we didn't want to distract from what's going on underneath. We wanted to keep it as plain looking as possible, and we did a very good job of keeping it plain looking. But what it is, overall, is we wanted to give to make the business case easy to understand, something fundamentally that people would use all over the place. And so what this is, it's line of business, meaning it's internal facing, and it's essentially a shopping cart. You go in, let's say, Nish, you're working internally, and I'm going to call up and say, hey, you know what? I want to order a concert ticket from Marina Rodriguez.
Yep.
And call up, and you're going to say, okay, it's going to be $45. I'm going to add it to the cart, and away you go. I'm going to confirm it, and then check it out, and go on and on. So it's a pattern here that we implemented, and look at that. I can go through and actually accept it and log in because it's all Azure AD enabled and things like that, and go in and everything is set up for you behind the scenes.
So as Matt mentioned, this is a line of business application, and it's a typical thing, right? So you want to integrate Azure AD to it, so that's all done for you here. And yeah, go ahead and complete the checkout, Matt.
Yeah, I just need your credit card.
Yeah, I can give my corp card. I'm pretty sure I can watch a concert while I'm here.
Yep. So anyways, we can go through things like this. And it's meant to be understood, stuff that you would face every day. All right, and hopefully I got everything, and we can go through and check out. So while we're doing that, what we delivered here, and I'll make it just a tad bit larger, is this is the GitHub repo. And as part of that, all the code, we have infrastructure code that you can deploy, which are in bicep files. And also, it links out to documentation as well, 6 videos over on the documentation on the Azure Guidance, Azure Architecture Guidance Center, and so on. So, and even instructions on how to deploy it yourself into your own Azure environment. So, pattern of patterns, everything that you need to actually go through and deployment. We booked our tickets. You're getting a barcode to go through and do it. So you see everything that you need to do, and you can give it to your customers. You can go to your user groups and talk to it. So it's meant to be reused by you in production environments and community environments, really everywhere you go. So this is what it looks like over in the Azure portal. And one thing I want to drive home is that we did not, it's real world.
Yeah,
mean,
it's a
look-
production implementation. So look at the
Exactly.
number of services, you could say that.
Exactly, yeah. We have app services here, we have Azure Redis Cache, we have a front door, we have a key vault, and we go down, managed identity for security, lots of security here, private endpoints, SQL Server, storage. It's the real deal,
Yeah.
essentially. So not even essentially, it is the real deal. And we have a dashboard, so you can go through and see what's going on. Obviously, right here, failed requests, I have my code has been merged, so we're here. Great. And so now we'll swap back to the slides and continue talking.
All right, Pat, where do we get this code?
Where do we get the code? We go to,
Oops, sorry, let's go back.
we go back. We go back one slide. We go to aka.ms/EAP.
RWA and .NET.
The EAP stands for Enterprise
App patterns. RWA is Reliable Web App Pattern, which is the first pattern that we built, and .NET.
Our favorite platform.
Absolutely.
All right.
Cool. So let's talk about our architecture a little bit. I mean, I talked about the line of business application. So you can see that it has Azure Active Directory, and the way we expose the endpoint, it is a public endpoint, and you see there is not many endpoints out there. So we are securing it by web application firewall, front door, and there's only one public endpoint out there. And rest everything, Matt, you can see that there are a number of services that's coming inside. They're working with the SQL Server, App Insights, blob storage, and so on. They're all connected through private endpoints, and this is the security best practices right there implemented, right? Centralized storage, Azure App Configuration, Key Vault, Secret Store, that's there. And the best way to build .NET applications and bring it to the cloud if you're starting on your journey, Azure App Services. So there is right there the monolithic application with Web API and, Web API and the web application itself out there. But, Matt, we're not building just the sample, right? We are going and building a real reference architecture, which means the business decides that, what is the SLO, again, the SLO was defined 99.9%. That's the target that we want to hit. How do we hit that? That's by going multi-region, right?
Right.
So this, the same thing, the same implementation goes into another region, and the way we connect with each other is through the front door. And again, as you see, the thought process is how do you look at the business context, go through what services to choose, and eventually how do we meet the desired business SLO? And this is pretty much very different from what we have ever built. It's more towards the customer scenarios, real world solutions. So customers feel confident to kind of look at this architecture and implement on their own.
I guess, yeah, just actually just hit me. We didn't even talk about this before. This is more than just a sample application, right?
Yeah.
It's, you have the sample, you have everything that you need to run the sample and learn, but you have everything around it too about why you would do what you do. It has context around it too. So why would you add that extra region? We'll talk about that.
Absolutely.
Why would you cut app config and key vault off from the internet as we talk about that? So yeah, it's actually really, really neat.
Absolutely. So let's go ahead and talk about the WAF pillars that we have implemented. So first is reliability. As applications come from on-prem to the cloud, you have to be reliable, which means reliability comes under important aspect. There are two things. One is how resilient your application is, and another is how available it is. We talked about availability, going multi-region, being there for the customer when they need to book a concert ticket, right? And being resilient is all about how quickly can you recover from failures. And failures happen all the time, Matt, right? There are a number of services. It's not the same in a single box. You have multiple services running. It's about multiple services running in multiple different boxes, and you need to connect to all of them. And you know that in the cloud, failures do happen, and they're mostly transient failures. So how do you recover from these failures, right? So that the whole idea is about putting that thought process and then designing your applications accordingly. And not just that, reliability is a foundation for everything that you build on cloud, because you have an opportunity to go distribute it in future. Remember, we were talking about the Relay Cloud concept, which is line of business application focused on employees, but it is a shopping application. So that means it has an opportunity to become a B2C, right? That means you have more services that you will build. Probably you'll use containers in future. You have chances of going into distributed, right? That means reliability should be a foundational goal when you bring your applications to cloud. And that's what we show by implementing these things. And the very thought process is designing for failures. As mentioned earlier, failures do happen. It's all about managing and handling the failures. Now, there are different developer patterns we use, and a couple of them, I will touch upon the two patterns that we use. One is the retry pattern, which, as the name says, whenever the services that you depend on fails, you retry, because there are chances that's a transient failure and it may come back up again, so you want to try again. So that's a retry. So you can create policies in your code, and then that will take care of retrying, right? And the other pattern that we implement is the circuit breaker. So remember, when you tried multiple times, there are chances to get denial of service. So you want to be away from that. So the way we do that is have a circuit that is open, so that no more requests go to other services. That way you're safe, right? The other thing is there are multiple business decisions that you can take here. For example, user has come to the screen looking for concert tickets and want to apply coupon to it, but the coupon service is down for some reason, it's not able to reach it. You can take a business decision, right? Hey, we're not able to reach the coupon service, mind we will give you a direct discount of 10% or something like that, right? So that just makes it even more better for the customers and building confidence in them.
Right.
Cool. So show us some demo, Matt.
Yeah, let's take a look at the code and see how we would implement both the retry pattern and the circuit breaker. So Nish, I know we were talking a lot about how this application that we have is going to be 100% production ready and ready to go.
Yeah.
Right, except it's not. Because what we did, we put in a mechanism to actually illustrate how to retry, just in case the web API portion of it breaks down. And so what this is just a configuration value and API app. This is over on the web API side. So the application itself is built up with a web API, web app calls the web API to get its data, calls over to SQL Server essentially. What we have is this right here, retry demo 2. And that's saying, you know what, during this retry demo, every other time, fail on me, blow up. And so now we're going to do our retries, so we don't have to give 10% off, because Relay Cloud is a very low margin business.
Yeah, this is the only non-production code, by the way.
Okay.
Yeah, that's because we couldn't make the Azure fail when we want to, so we had to bake in some sort of simulation to show how we implement this.
Right. So generally, the code always fails during demos. But all right, so we have this up and running. So this is Relay Cloud going locally. This is the web API going locally with the Swagger UI tooling. All right, so what happens? It's going to be failing when I go through and hit upcoming. And this is local, so it has to spin, fail, no concerts. Every other time, success.
Oh, there it is, yeah.
Fail, success, fail, success. You could do this all day long. It won't get old to me. All right, but let's fix that. Let's make it so it doesn't do that any longer. First thing, though, I want to talk about is there's a lot of ways that you can add in different retries, ways to do different retries. And you can use Poly, the NuGet, the community library. You can use Poly, but ideally, before you go that way, if the client library that you're using offers its own built-in retry policies, go ahead and use that. So right here, we're looking at newing up with Entity Framework. And Entity Framework, when it calls the SQL Server, offers its own enable retry on failure policy that I have highlighted here. So something happens, it takes too long. Let's say we're using SQL Server serverless or something. It takes a little bit to spin up and you get a timeout. It's going to try its own retry policy here. So that's what we're doing. So if the client library offers a retry, use that. So that's part of what we're talking about in the prescriptive guidance. And you can see another one happening right in here, this highlighted code. This is actually calling over to Azure App Configuration to grab, configuration values. And right here, configure the client values or options. Again, retry delay, how often I should call it, 1 second, maximum 3 times before you blow up. So internal offers it, then use it. All right, so let's actually implement Poly then for our concert search. All right, so I have the retry policy already created, so I don't have to type and make a bunch of typos. And this is what it will look like. It has a decorrelated jitter backoff v2 policy, which is just like a random type policy that says delay, 500 milliseconds, do it for three times.
Yeah, again, these are best practices so that you don't hit denial of service, so you create exponential backoff.
Right. right? And then we can even go through and say, hey, Copilot, what does that do? And say, hey, I know
You do that?
I told everybody I would do this. What does the?
This was not planned by the
No, I
Yeah.
had to do.
So we have no idea what's going to happen.
Yeah, what does the highlighted code do? Come on, Copilot. Yeah, look at that. It's an algorithm used to calculate the delay between retries. Enhanced version of the jitter backoff algorithm.
Matt, you didn't need me.
Who knew?
Wha-
Who knew? Oh, anyways, so you do this, right? Get retry policy. And then down here, what we're doing here, the add concert context service. So we have just a service class, and the service class's whole purpose in life is to call the web API via an HTTP client, right? And so what I'm going to do right here is add on to that HTTP client that gets injected into that service class is add the policy to it, add the get retry policy. So now, that retry policy, because I'm only failing every other time, because I have it set so it is 3 times, it'll try 3 times, because I'm only failing every other time, we should be guaranteed to work. So I'll restart the web application, and once it gets going, I'll hit the get upcoming concerts, and I shouldn't see that little blue dialog saying it failed to get the concerts back. And here we go, upcoming, spinning, Swagger UI tooling, good. Upcoming, good. So it worked, our getting a retry worked. Awesome. So what I can do then really quickly is I can go back into app settings, make my retry demo to 1, saying, hey, fail every single time. Now what's going to happen then is that the retry, I could get, as you mentioned, a denial of service attack on my own services, which isn't super cool. So what I would want then is to do a circuit breaker pattern. And what this is saying right here is that if I fail from a transient HTTP error code with 5 times within 30 seconds, give up.
Yep.
Give up and throw an exception so we can offer a coupon code. So it's the same deal down here. All I'm doing is chaining on a new policy handler and saying, give up and throw an exception. And make sure I have the parentheses correct. Run it again. And as soon as that spins up, I'll be getting failures because every single time it will never succeed. And then once I go back, I'll be able to see an exception that actually throws back in the output window the debug setting. Here we go. Swagger tooling is up. Both my apps are happy. Upcoming. Should see a failure. Failed. And I'll just hit it a bunch of times so I can see everything in the debug. I'll stop my app so we can see it not come through. Output. And if I wanted to catch it to give out the coupons, right here, broken circuit exception. So when you get that, it's not even bothering anymore. It's just saying, you know what, it's down, give it up. So a lot of times, not only our services we should do it, any third-party services that we're calling, we don't have any control. They could just go down. So we want to implement this anytime we're calling out to a web API.
That's right.
Cool. So we'll jump back over to the slides and start moving on to our different pillars.
Cool. Let's talk about security, man.
All right, the security. This one should kind of go on said why we need to implement this. And there's 3 big reasons, I guess, other than hackers, why we would want to is confidentiality of data. We don't want our data leaked all over the internet. You want to stay off the front page of the Seattle Times and every other newspaper in the world, I guess.
Sure.
Newspapers, nobody reads them, just me. Integrity, data integrity. Not data could get leaked, but people could also go in and mess it up. Inside, you want to keep it nice. And availability. You just want to make sure your apps stay up and running. You don't want something happening where it just goes down by malfeasance. And so what we have here then is the security pillar. And the best practices or the patterns that we outline here are both managed identity and identity-based authentication, which I'll talk about in just a sec, secret management, and then endpoint security. And with endpoint security, that's when we kind of loop things off from the public internet. So you can think of like app configuration and Key Vault, where our settings are. There's no reason that we need to get at those settings from the public internet.
Yep.
We can just have our app services, our web servers, so to speak, They just need to hit it. There's no reason why I would need to hit it from a REST endpoint. Keep them secret. Keep them cut off. Or SQL Server. Why would I need to actually hit it from the outside world? Let's just keep it all within Azure.
Yep.
So that's what endpoint security is all about, and we talk about how to implement this in the pattern. But then managed identity and identity-based authentication. This is super cool, and I just love it. What you can do, this is passwordless connections for your servers. So let's say you have, normally you would get to SQL Server with a connection string.
Yep.
It's getting rid of that connection string. So our app service, we're going to say, app service, you now have an identity within Active Directory. And now that you have that identity, we're going to grant you access to other Azure resources. We'll grant you access to Key Vault to be able to read certain keys or write to certain keys or to app configuration or even to SQL Server. We can do that. And then that's the identity-based authentication portion of it. So we create a managed identity for it, and then we get the identity-based authentication for it and be able to grant it specific things for it. And so that's cool. Get rid of all those connection strings so you don't have to actually worry about managing any connections.
Yep.
Awesome.
Avoid the leaks.
Or avoid the leaks. Sometimes you can't.
Yep.
Though. Sometimes not all services are passwordless yet or managed identity enabled yet. They're getting there, but not everything's there quite yet. And you might need to do some secret management. Or if you're calling third parties, you might have
Third
some
parties,
keys,
yeah, absolutely.
keys for that too. So that's where Azure Key Vault comes in. So pop it in Azure Key Vault, eliminate access from the public internet to Azure Key Vault, and then get at it that way. So Azure Key Vault has managed identity, and so kind of go that way. Managed identity, Azure Key Vault, only what you need to get at from your application, and then there you go. And what's cool about Azure Key Vault, you can version your secrets, and obviously just say, Nish, you can get this one secret, Matt, you can't get at this other secret. It's really, it's top of the line security. And then getting into cost optimization, or keeping things cheap. So Nish, this is our reference architecture. And when I look at this back when I was doing contracting and consulting, when I look at this, I see one thing.
Cost.
Dollar signs. I see dollar signs that this could get very, very expensive very, very quickly. And so we want to make sure, even if it wasn't this big, even if we're just running one app service, we want to make sure that our costs are under control. We want to make sure that things don't get out of hand. And that's where cost optimization gets into play. And we outlined several different ways that we can do that. And one of them is making sure we choose the right resources for the job. And what I'm talking about here are SKUs, or like how big and powerful various servers are. And so like Azure Cache for Redis, right? There's a basic tier and then there's a standard tier, basic being a scaled down version. If I'm doing development, I don't need to use the big one. Or if I'm doing web, if I have my app service, and even in production, if it doesn't have to be the really large one, I just have to make sure I use the one that suits my workload. And I can scale it up later if I want to, and that's what the second point is. Write some scalable rules, put it into your infrastructure as code that says, all right, if my CPU gets to 80%, scale it up if I need to. Things like that. And then dynamically allocate and deallocate resources. And what we're talking about here, Nish, as we are writing this talk, I realize that you like to take vacations. Mm-hmm. So what I do then is that for dynamically allocating and deallocating is that when you're gone, wipe everything out. And if we're using infrastructure as code, we can then reallocate it. It's super easy. Just spin it back up.
Yeah, and the other situation is when you have production and development, your dev environments don't need to cost so much as production, because production needs that kind of a scale, that kind of SKUs where you want the high availability and so on. We don't need that for development. Right. So you can do choose between those things as well, or on those configurations as well.
Exactly. And we go through in the documentation that we came along with this on how to pick this out. So this, I actually really love how this is. So we're talking about how to calculate a service level objective, or SLAs, SLOs, kind of both the same thing. And so let's say the management of Relay Cloud wanted to hit 99.98%. And so then to calculate what you're going to get, how to hit that, you have to take each and every Azure resource that you have. Each of one of those has its own SLA, or a service level agreement. And that's really saying, you know what, I'm Azure Key Vault, and I guarantee I'm going to be up like 99.99% of the time.
Right.
Right? And so to get everything together, what you do is you multiply it. So every service that's in there, you multiply them all together, and then that's how you figure out what your uptime is. And for what we're showing here, or for what you get with Relay Cloud, I think it's like 99.5 something or other. And that is below what the management wanted, because that gets you down to like 38 hours, 35, 36 hours of downtime a year, which actually is quite a bit. 99.56 sounds good. That's a day and a half of downtime. That's a lot of coupons you're giving out. So what you want to do, most likely then, is add in another Azure region to keep your uptime up. And there's a formula to actually figure this out, which I had no idea until I saw it, as the folks who are behind this pattern figured out for us. And the formula is 1 minus n raised to the number of Azure regions, n being the number that you just calculated up above, so in this case 0.9956. Square it to get 2, then you get 99.99%. But you have to find a way to get your traffic.
Yeah.
One Azure region goes down, you have to find your way to get the traffic to the other Azure region, Azure Key Vault. So now you have to multiply that by 99.99%.
Azure Front Door.
Front Door. Did I say Key Vault?
Yeah.
99.99% with Front Door, and you're back to 99.98%. So it's a lot of 99.99%. Important part is 1 minus n raised to the number of Azure regions, and there you go.
Yeah, again, the important point here is how do you calculate this so that you can keep your business running? And that's the whole thing. I mean, the whole App Patterns is about understanding that decision process, and sometimes the management wants to know, right, what is the uptime, what is that something which we can absorb, and so on. So you define these things. Once you define that business, then you actually go and calculate this. And these are, it may look difficult, but as Matt explained, it's pretty simple to do it. But then, that explanation needed to be there, and that's there in our guidance.
Exactly. And maybe it's totally cool to be down for 30 hours a year. It's an internal app. It could be even more. So you could pick your SLAs based off your SKUs off of that. A lot of acronyms that start with S in this calculation. So let's take a look back then at deploying RWA. And we deploy RWA via bicep files. And bicep files are super, super cool because it's infrastructure as code. Also, though, you can do variables, you can do if statements, you can do functions within bicep files. And this gives us the ability then to say, you know what, if I'm in production, if I pass in a production parameter to this when I'm actually running it to provision my resources with AZD, I can say, you know what, isprod is true, so I want to do the standard version of my Redis cache SKU. If not, just make it basic. And then later down, we're just highlighted when I'm doing provisioning, I can set my SKU name to be standard or basic. So it all is based off of a variable, or parameter that I pass into my Azure AZD CLI, command developer CLI that I pass in. Way I have my bicep files structured, development, production, I can really bring down my costs of development just off of this, just off of Azure Cache or Redis, bring it down 16%.
Yeah, how cool is that, Matt?
Cost.
Dev costs 16% of production.
Right.
It's amazing.
Yeah.
Right. Cool. So let's talk about operational excellence. I think we briefly touched upon a few things, but we'll go again. One is the repeatable infrastructure. That's what I was talking about. Matt touched upon that. We decided how to choose on a Redis cache, choosing the SKUs and so on. The whole idea of operational excellence is what are the set of processes to keep your applications running in production? And that's the important aspect. And there's also monitoring where you implement. So there are multiple services that is coming together, and you need a wholesome way to look at how are other services connecting with each other? Where are the failures? Matt implemented the retry and circuit breaker. That in reality, they are actual services failing, and you want to know where exactly is failing and what are the methodologies that you can utilize to kind of like recover from them. And all those things available in a dashboard, and that's what you need to ensure that you enable that. And then in Reliable Web App Pattern, we implemented pretty with easy way to do that so that you can, take advantage of this code, implement it in your own applications as well. Now, as part of automation, we'll touch upon the rotating secrets, right? We talked about managed identity, which takes care of you don't have to worry about client secrets and so on. The reality is you may be working with many services where you have secrets in it, and that's why you go with Key Vault to keep the secrets. But the challenge is if things gets leaked out, how are you going to handle it, right? So you need to have some sort of process in place, ideally in a DevOps, right, where someone like Matt will call up and say, hey, there's a leak, can you wake up and just rotate the secrets? He's going to do it, right? So you need some sort of an automation to be done, and that's what we're going to talk about in the operational excellence, right? So I talked about this. There are secrets which are used to grant authorization, so you want to keep it safe. And rotating the secrets provides you protection, which means it's not just about when it leaks, but also you can have practices like rotate it once in a while, maybe in a week or a month, you define it, and then that needs to be, again, an automated process, right? So what is a general process to do that? One is find out whether you need to rotate the secrets or not, right? Then you generate a new key, you update that key in the Key Vault, and then restart the web app, and that's it. And that will take care of rotation of secrets. Now, while restarting the web app, there are challenges with that too, where your uptime and downtime goes again. Again, find out how to do that. We recommend using deployment slots and so on, so that you don't have the downtime even doing these operational aspects. Again, thought process on how do you do production, how do you do application production with full confidence, and that's what we keep covering on these aspects. Little bit more on the repeatable infrastructure side. We talked about infrastructure as a code, and Matt showed you bicep templates. You can do ARM templates. You can do Terraform and on as well. And also, bug fixes. For example, if one environment has bug fixes and you want to scale it out to multiple things, means you having a repeatable infrastructure ensures that it's the same environment in multiple, same infrastructure in multiple environments, so you can automate those things very easily, maximize productivity. I mean, that's it. That's the thing all about, right, Matt? Is productivity. That's so important right now. Mm-hmm. Okay, and with that, we'll talk about the last pillar.
All right.
Performance efficiency.
Yes, we'll get to the very last pillar of performance efficiency, or we're making our apps faster. The last pillar of patterns. And really, we want to make sure our applications can meet any workloads that are placed upon it, right? We don't want to, and this actually kind of goes back, as we mentioned before, to resiliency, right? We don't want to crash. Nish, you're pessimistic. You say you want to design for failure. I want to say you design for success, so you don't crash underneath heavy load. But anyways, so performance, you want to make sure that things can scale out and be good, right? You're still responsive, that you can maintain your consistency under heavy load, and that you also want to make sure you manage costs. Costs go into performance efficiency as well. So one thing that we talk about here in the RWA section of things is the cache aside pattern. And so what this is that cache aside pattern is Azure Redis cache, Azure Cache for Redis. What it is that you put a Redis cache in front of Azure SQL, and if you put your highly data that gets used a lot, pop that in Azure Redis cache, Azure Cache for Redis. You put that in there, and so that data is only read from the cache quicker. It's quicker, it's faster. Performance efficiency. It also is not hitting the database, so it's not overwhelming the database. It's also keeping your costs down too, because you're not querying the database so much. So it's cool, right? You have it there. But the thing is, though, when you take charge of puts data into the cache niche, you got to make sure it's consistent.
Yes.
Into the database too. So you get, but you have to give a little bit. You have to take control of your data. You have to make sure everything stays consistent. So we'll take a look. We'll jump over to the code here to take a look at how to implement that to get Azure Cache for Redis into the code so things are a little bit faster. So the first thing here is this is the data. It just calls over to Entity Framework, which hits Azure SQL. So this is the create concert function. And what I have highlighted here, database.add, await database.save changes async. Super, super easy. All it's doing is saving a new concert to the database. However, our underlying database just changed, right? So now anybody who hits the cache is not going to get that new concert out, right? So we want to get that cache empty. And so what you do is you do this.cache remove. Where did that cache variable come from? It came from a NuGet package that's called
Stack Exchange Redis.
the Stack Exchange Redis. So what you do is you put the Stack Exchange Redis NuGet package into place. It's in the startup file, add distributed session, right here. All you're doing is you're putting it into the middleware and just say, you know what, here's my connection string for it. And so it gets into the middleware, and then you can just inject it into your various classes that you want to use it in. So it's just this.cache, which is a iDistributed up here, iDistributed cache variable type, and then away you go. You could also then just use, you didn't have it and you wanted to go with pure, you could just do the distributed memory class cache, which is just the, it would go away once the database or once the application went away. Not using Azure Redis cache, in other words. All right, same deal with update concert async. Database changes, remove it. Delete concert, same deal. Database changes, remove it. Now, before I move on, Nish, you'll notice that we're just saying remove cache keys, upcoming concert. So that really our whole caching strategy is key values.
Yes.
Right?
Yep.
And that's important. That means we can throw any type of data that we wanted to into the cache, and that's one of the best practices we talk about. Don't use different caches for different data sets. Serialize them as JSON and throw them in there. Save a little money.
Yeah, again, identifying in your business application where exactly you need that kind of a performance, that's where you want to go and implement the cache aside pattern, right?
Yes.
In this case, we are using for the shopping cart, so it makes sense. But in your application, it could be somewhere else. But the whole idea is to show you how to do that and how do you decide when to do that. And that's what we cover in the details.
Yep, you do it when you need data that's fast, and highly retrieved data is really where you go at it.
Yeah.
And so to get it out, hey, cache, get me a string async based off my key. If it's not there, or if it is there, if it's not empty, deserialize it. Just like we're calling a web service, we want to deserialize the JSON that's coming back. And then you return it, because we have it deserialized. If it's not there, pull it back from the database just like you would normally from Entity Framework. Get it back from the database, serialize it into a JSON string, create expiration on it so it goes away eventually, because every now and then you are going to want to refresh it just in case.
Yep.
Another best practice. And then put it back into the cache by using setString async with that key. And then return it. So essentially, check the cache. If it's there, use what's in the cache. If it's not there, grab it from the database, pop it into the cache, return it.
Pretty straightforward.
Yeah.
Cool.
Awesome. So we'll hit back to the slides. All righty. So Nish, where do we get the code again?
aka.ms/EAP.
Enterprise App Patterns.
RWA.
Reliable web app.
.NET.
Favorite
Very
platform in the world. All right, so we are running short on time. So if anybody has any questions, we do have a discussion session coming up at, I've been told, what, 4 o'clock?
Yeah, 3:45, 4, yeah, 4 I think.
4 o'clock, yeah. So it's a discussion session 104. It's down on the 3rd floor. Nish, and we'll have some people from the engineering team who actually came up with all the heavy lifting behind this there too as well to answer any questions that y'all may have. So DIS 104 down on the 3rd floor, starting up in a half hour.
Yeah, and for the folks online, I hope our friends would have already answered the questions for you. So this is great. Cool.
And, of course, follow .NET for all the things. We'd be remiss if we didn't talk about this, because we have .NET everywhere. We have like 6 videos about the reliable app pattern out on .NET. We're always talking about the reliable app pattern. This, as Nish alluded to in the beginning, is evolving. And more, we'll have modernized, we'll have scalable, and we'll keep on going. So it's going to be on .NET, all the things, .NET on Mastodon. Who knew? .NET and TikTok.
Wow.
They don't let Nish and I use it because we are over the age limit. YouTube,
Wait, Matt, you are, not me.
Nice one. Twitter, all over the place. So follow us everywhere that we can go. And please review the session as well. So, yeah.
All right. Thank you so much, everyone. It's been a pleasure chatting with you. Thank you, Matt.